Okay, so ball of mass m moves with speed u at an angle a to the horizontal until it hits a small horizontal barrier. After impact, it moves with speed v at an angle b to the horizontal. Show that the coefficient of restitution e is given by the following. Now, the first thing I'm going to do is I'm just going to make this equation much simpler idea than the one we're just doing. Here's my idea right now. Okay, if you imagine it's the formula is phi equals minus EU. And for argument's sake, imagine the barrier I created there is an E value of a half. Okay? And for argument's sake, my red ball comes in. It comes in at a speed of 5 across and 10 down. Okay? 10 down is technically a minus 10 because it's going downwards. Okay? Now, this means that my speed going upwards will be, because the 5 is parallel to the plane, or parallel to the barrier it's going to hit. This speed after impact will also be 5. But what gets changed is the fact that it's on its way up instead of its way down. So v will equal minus e, which is going to be minus a half times minus 10, half times a half, and v is going to be 5. That's going to be plus 5 upwards. So it's going to work something like that. Okay? So I'm going to do a similar system here. Okay, I'm going to take negatives into consideration as well. I don't think the solutions did it this way, but I'm going to take my negatives into consideration as well. So what we're first going to do is going to use alternate angles. So if you know what I mean by an alternate angle is that if you ever have a Z where the two parallel lines, you know that that angle is the same as this angle here. What I'm going to do quickly, just to save myself a bit of hassle, is I'm going to just draw a line here like so. Okay, and down. And that A here is the same as this A here. That's U. This makes this speed u cos alpha going to the right and u sine alpha going down. Now, because the u sine alpha is going down, it's a minus u sine alpha, in my opinion, right? So we have the velocity in the x direction and the y direction. So if you want to do it as, you can do it as this u equals u cos a I minus u sine a. For example, 5 across and 10 down is the vector 5i minus 10j. Direction is the same thing. So it means the same. Now, next we're going to look at the next part, which is a B. B is in the correct position, so I don't really need to worry too much about B. So there's going to be two things here. It's going to be this is going to be phi sine B, and this is going to be phi cos B. Oh, sorry, phi cos B. Hopefully, all right, everybody. Now, the key to remember from my example earlier, where I said that the e value was a half, I said you were going 5 across and 10 down, and then at the end you were going 5 across and 5 up. The thing you got to remember is that the I value remains the same. So this is true here as well, that u cos alpha is going to be the same as b cos b, because your final velocity is v cos b I equal plus phi sine b. Okay, so we know that much. So we know that phi cos b has to equal u cos a. Okay, so that's the first thing we learned. Do this. We hope we can get the answer of this pretty quickly. What we're going to say is u cos a phi cos b. Okay, now we're going to do our formula. Phi equals minus EU. Remember I said 5 equals minus a half times minus 10 because it went downwards earlier, something like that. We're going to say that v, which is this is in the j direction, because the only things that get changed is the j direction. This part here gets changed because it was going down and now it's going up. The blue part is the part that changes and the yellow part stays the same. So along the j direction, it's going to be phi sine b ends up to be equal to minus e times minus u sine a. And what we can do here comes very obvious what we're about to do in a second. Comes e u sine a equals phi sine b. Now, here's what we're going to do. We're going to substitute out v. So see the v in this equation up here? I'm going to get phi equals u cos a over cos b. So check this out. Going to substitute out that v. So it's going to be u cos a sine b all over cos b equals e u sine a. And here's what we're going to do. I'm going to have cancel the u's. Sine b over cos b is tan b. Bring the cos a underneath. So we're going to get e sine a over cos a. And sine a over cos a is in fact tan a. And then e equals tan b over tan a. So e equals over tan a. And you're done. Happy days. So that's 12. Next one. A mass of 0.1 kilograms, I assume it's kilograms, moves horizontally with speed 25 meters per second towards a smooth barrier xy, which makes an angle. Now, angle A equals tan inverse over 24. This implies that tan A is 7 over 24. It's money. It's a 7, 24, 25 triangle. I'm pretty tired, so I'm just going to make sure it is in fact what I said it is. Yeah. Okay. So that means that cos A 4 over 25 and sine A is 7 over 25. Happy days. Now, E value, 7ths. Happy days. Find the speed of the ball after impact. Speed means, for example, if it was going 3i plus 4j, that's not its speed, it's velocity. So speed would be the hypotenuse of that triangle. 3 across and 4 up is the velocity in terms of vectors. Remember that when you're getting the answer of the question, okay? And let's have a look at the actual diagram. Now, this diagram is wrecking my head. So I'll explain how I'm going to fix this diagram to make it a bit nicer on my poor brain. The smartest at times. So here's what we're going to do. I'm going to rotate it like this, and I am going to make it so. This is now my x-axis. That's my x-axis right there. If you remember, z is alternate angles, x is opposite angles. This angle equals this angle, so this is going to be angle A for me. Okay, and then it's going to hit. The ball is going to hit. So this ball is going to hit the surface, and then it's going to rebound like that. Okay, so this is what we're going to do. I'm going to rebound it out here. Okay, and for argument's sake, I'll call it angle. And here's what we're going to work on first. Let's work on the 25. Let's see what way it's going down and across for me. Here's what we're going to do. 25 cos A, and this is going to be 25 sine A. And we know that sine A is 7 over 25. We know that cos A is 24 over 25. Well, Look, for me, that means 7 down, 24 across when you multiply it out. 7 down, 24 across. 7 on its way down, 24 across. Now, please remember that your I component remains the same. So it's still going to be 24 on the way out. On its way up and out. For struggling to visualize it one more time. It's going to go on its way down. Now it's on its way up. Okay. Oh. And then to make this whole thing a bit easier to visualize, I am going to destroy it. Easy peasy. Now it looks nice. Now, 24 on the way out because its speed is preserved. Blue. But we have to figure out what happens to the 7. Well, we know that it's going to be 3/7 of its initial speed. So V equals minus EU. 7 on its way down is minus 3/4 minus 7. Sorry, minus not 3/4, 3/7 of minus 7. V value of plus 3. So it's plus 3 on its way up. Its speed is the hypotenuse of this triangle, which we'll call not S subscript. S subscript P is going to be the square root of 24 squared plus 3 squared. 24 squared plus 9. Square root it. 3 root 65 or 24.19. I like 3 root 65 meters per second. Alrighty. Magnitude of impulse due to the impact. Okay. The magnitude of the impulse. It's been a while since I did one of these. Impulse is the following formula. Now we're going to come at it from 2 angles just to be you know what you're doing. NV minus MU. It doesn't matter. The 2 lines means take the positive value. Okay. Now, for argument's sake, we could try. Now, which speed are you talking about here? Are you talking about the vectors, or are you talking about the actual speed? Let's see if there's any difference in the answer. Okay, so we're going to go for I times mass is what is the mass? The mass is 0.1 kilograms. 0.1 kilograms multiplied by its final velocity, which is 3 root 65, minus mass, 0.1, times its initial velocity, which is our initial speed, which is 25. Now, I don't think this is going to give you the right answer. Okay, so I just want to make this mistake for you. So, we do an exam. Okay, minus 0.1. I'm using speed here, not velocity. Okay. And we can see our answer is 0.08. Okay, and I don't think 0.08 is the correct answer. Just to be sure, we'll check the solutions. And it's not. Okay, now here's the better way of doing it. The way to do it is there's 2 ways. You just do it in the direction in which the motion took place. So the first way of doing it is just ignore the 24s and just concentrate on 7 and the 3. Okay, so it's going to be 0.1 times plus 3 minus 0.1 times minus 7. Please remember it was a minus 7. And your I equals, it's 0.1 times 3, which is 0.3 plus 0.7. Our I value is 1 Newton per second. Remember, or sorry, Newton seconds, not Newtons per second. The actual unit of impulse is Newton seconds. Okay, and that's the correct answer there. Now, the other way of doing it, write them both in vector notation. which is u is -7. Sorry, u is 24 I, -7j. V is 24I 3j, and you just lob them into your formula as shown. So you go for 0.1 24I 3j, and then you do minus -0.1 and 24I minus 7j, and then what you end up with is the 0.1 24 cancel. You're going to end up with 0.3j plus 7j, which is 1j Newton seconds. It basically means it's an impulse in the j direction. But once again, you don't have to do it like that. You can just basically ignore the values that are the same and concentrate on the j values where it actually changes. Okay? So that's your impulse done. Find the loss in kinetic energy to the nearest joule. The loss in kinetic energy, well, this is an easy one, thank God. All right, so the easy one is it's kinetic energy before, take away kinetic energy afterwards. This is a handy one first, so it's a half. The loss in kinetic energy, a half mv squared before minus a half mv squared after. Ke before, Ke after. So we're going to get a half 0.1 times 20 squared, half 0.1 times 3 root 5 squared. I'm going to be a bit easy and just look up the answer. 2 joules, more than likely. 2 joules is the answer. Right, we'll do it out. Wait, 5 times 0.1 times 3 root 65 squared. 2 joules. Alright, happy days. Always check your answer. Next one. Hopefully I won't need this, but if I do, it's there. I'm hoping I don't need it. I'm just gonna put it up here, to be honest. Now, a smooth metal sphere falls vertically and strikes a smooth plane inclined at an angle theta to the horizontal. It's a coefficient of restitution, so E equals 2/3. And the sphere rebounds horizontally, calculate the fraction of kinetic energy lost during impact. So it doesn't matter, we're going to assume it hits it at you. Find the fraction of energy impact. Alright, it's an interesting one. Okay, here's what I'm going to do. I am going to get this. I'm going to grab this here. I'm going to send it to a current page. And here's what I'm going to do. I don't like them like this, so I tend to do. I'll show you my little trick now. So once again, alternate angles. That's theta because of the z. Okay. So what I'm going to do is I'm going to grab this. Sorry. Group it all together first. Control group. There we go. And next thing I'm going to do is just going to shrink it down a little bit and rotate. This is what I want to use. So that it's the x-axis is what I'm used to. Okay. Now that's theta, and this can be angle. Does it even have an angle? Oh, do we have an angle? Theta. So what we're trying to do is calculate the Energy loss during the fraction of energy loss during impact. Okay, fun times. Now, I think we have this straight angle. I'm not introducing A here. I don't want to introduce A if I can help it. Straight angle. That would mean that this is 90. And if that was still A, I'd say that theta plus 90 plus A equals 180. This means that A on its own, oh sorry, A on its own would be 90 minus. Okay. Now, something very important for you guys while we're at this. I'm hoping something really small over here. Cos, uh, cos 90 minus theta, same thing as sine theta. Now, if you aren't sure about this rule, or technically sine 90 minus theta is equal to cos theta. Now, if you aren't sure about this rule, here's what I suggest. Pick any number. So if I chose theta equals, I don't know, 40 degrees, what I'm claiming is that what I'm claiming is that sine 50 degrees is the same as cos 40 degrees. And I'm also claiming that cos 90 minus 40, 50 degrees is the same as sine 40 degrees. Well, let's find out. Cos 50, 0.64. Sine 40, 4. Sine 50, 0.766. Cos 40, they're the same thing. Okay, so just remember those two little rules just in case you happen to need it anytime soon. Okay, now, in fact, I can probably arrange this in a way that we might not even need that rule. Okay, so I'll just store that rule up here just in case we happen to need it, but I don't think we will. Now, here's what we're going to do. I'm going to calculate u. Now, here's u here, okay, and it's undergoing this big triangle here, and that's, oh my god, that's 90 degrees coming this way. Now, this angle B is going to be theta, believe it or not, because you're gonna have 90 degrees here, so you can have 90 minus theta, then the 90-degree angle plus 90, and then you have B equals 180, and this implies that B must equal. Now I know that B equals theta, so I can get rid of that 90 minus theta business there if I don't want it. I'll just put theta here. Okay. Now I can break u up into its components for myself. Okay. So this is going to be u cos theta on the way down, and to the left it's going to be u sine theta. So velocity u is going to be, technically it's minus u cos theta I, because it's on its way down, and because it's going left, I usually associate left with negative, minus u sine theta j, down and left, which is usually two negatives for me. Okay. Now, for v, what we have for v is we're going to have phi cos theta. Yeah, phi cos theta in the I direction, and we're also going to have phi sine theta, and it gives us an e value of 2/3. Okay. And that's phi cos theta I plus phi sine theta j. Now it's plus phi sine theta j because it's on its way upwards. Okay, up, that one's on its way down. Sorry, that's left. Now, what we know is that these two are the same thing. Two yellow parts are equal to each other. u cos theta therefore must be equal to v cos theta. Oh, sorry. I got it's that one mixed up there. Again, going to the left, which is minus u sine theta. It's going down, so u sine theta I minus u cos theta j. After speed is minus phi I plus phi sine theta j. And what we're going to have here, lads, is the yellow parts equal each other, like so, and the blue parts are different because they're the parts that get changed by the impact in the j direction. Okay, so the first thing we can now say is that u sine theta equals phi cos theta, and then we can say that sine theta over cos theta is tan theta. Tan theta equals u over no, we messed that up. Phi over u. Cos theta under sine theta is tan theta, and then phi divided by u. Okay, tan theta right there. The next thing is we're going to go for what we always do. Phi equals minus eu, blue part. So your final velocity, which is phi sine theta, is minus 2/3 u cos theta. Minus 2/3 minus u theta. And what this means is phi sine theta 2/3 u cos. And if we bring the cos theta underneath, we get phi tan theta equals 2 over 3 u. 2 over 3 u. Now, tan theta equals phi over u. Tan theta equals phi over. So we're going to get phi times phi over u equals 2/3 u. We're going to get phi squared over u equals 2/3 u. Then we're going to get phi squared equals 2/3 of u squared. I think that's going to be what we need. Now, what do we need? Calculate the fraction of energy lost during impact. Fraction of energy lost during impact. Fraction of energy lost during impact is Ke before impact, Ke after impact divided by Ke before impact. It's going to be a half mv squared divided by a half mu squared, and it's going to be a half m, it's going to stay the same. What we now have learned is that we can substitute phi squared with 2 over 3 squared, and then everything cancels. Squares cancel, the halves cancel, the m's cancel, and we realize the answer is 2/3. I hope. Let's find out. So 2/3 of the energy is preserved. So because the K afterwards is 2/3 of the K before, this means 1/3 is fraction of kinetic energy lost. 2/3 is preserved, 1/3 is lost. Alright guys, that is questions 12, 14 and 15.